Hi Algebra 2 students, this video is for Friday, October 24th. On this slide you see the warm-up for today. So go ahead and take out your composition book and complete the warm-up in your composition book. Make sure you're writing down the directions in addition to the problems. You're going to need to hit pause on the video. Once you're finished, go ahead and restart the video. Please hit pause. Okay, let's check your answers for 1 and 2. Find the value of c that makes the expression a perfect square. We take the b term, divide it by 2, and square it. So c would make this trinomial a perfect square. Take the b term, divide it by 2, and square it. C would equal 1. The directions say solve the equation using square roots. So first I factor x squared plus 4x plus 4 factors to x plus 2 times x plus 2, which factors to x plus 2 quantity squared. Then I square root both sides. I get x plus 2 equals plus or minus 5. So x equals plus or minus 5 minus 2. Separate it to get my two solutions. And so x equals 3 and negative 7. On number 4, factors to x minus 10 times x minus 10. I square root both sides. The square root of negative 36 is plus or minus 6i, so x equals 10 plus or minus 6i. Okay, let's get started for today. Okay, so today we learn another technique for solving quadratics. We have graphing, factoring, square rooting, and today we add completing the square. Okay, so completing the square is using the idea of perfect square trinomials. You're going to need to see a few of these before you get the hang of it, but then once you see a couple, it's no big deal. So stay with me, make sure you're taking notes in your student journal. I'm on page 58, and you may need to hit pause on this video to write some things down, and that's okay. So when we complete the square, the first thing I want to do is get the a and b term on one side. I'm going to move this c term over to the other side by adding 2 to both sides. So I'll have r squared minus 6r, I'm going to leave a space, equals 2. What I'm going to do, I'm going to complete the square by adding the same number to both sides. So I'm going to find the c term that makes the left a perfect square trinomial. So to find that c term, I take the b term, negative 6, I'm going to divide it by 2 and square it just like we worked on yesterday. So negative 6 divided by 2 is negative 3, squared is positive 9. What I'm going to do now is I'm going to add 9 to both sides. That is a legal algebra move because I'm doing the same thing to both sides. So my new equation becomes r squared minus 6r plus 9 equals 11. What you should notice on the left is that you have created a perfect square trinomial, which factors to r minus 3 times r minus 3, which can be rewritten like this. And hopefully as soon as we get into that form, you realize that now I can solve by square rooting both sides. So I'm going to square root both sides, and I get r minus 3 equals plus or minus square root of 11. So r equals plus or minus square root of 11 plus 3. And that's my final answer. So let's go back and review what we did. We started by leaving the a and b term on one side, moving this 2 over to the other side. I take the b term, divide it by 2 and square it. This is the completing the square part. I go in and put the 9 on both sides. I factor using perfect square trinomial and then solve using square roots. So let's try again. On number 8, we start by leaving the a and b on one side, moving the 28 over to the other. So I would have x squared plus 10x equals 28. Oops, and that should be negative. Notice again I left that space. I'm going to figure out what that c term needs to be. So I'm going to say c equals 10 divided by 2 and square it. So 10 divided by 2 is 5, squared is 25, which means that I'm going to add 25 on the left, add 25 on the right. So my new expression becomes x squared plus 10x plus 25 equals negative 3. I'm going to factor my perfect square trinomial on the left, factors to x plus 5, quantity squared equals negative 3. Now I can square root both sides. So x plus 5 equals plus or minus I root 3. And now I'm going to subtract the 5 over. X equals negative 5 plus or minus I root 3. And that's your final answer. Not so bad, right? So let's do it a few more times, make sure that we're feeling okay with this. Now we're going to take a look. We're going to skip number 9. We're going to go on to number 10, actually. So let's take a look at 10. And hopefully something right away looks different about 10. This equation has a leading coefficient. So we're going to go ahead and we're going to get rid of that leading coefficient, dividing every term by 2. Including the 0. And this cleans up nicely to t squared plus 8t minus 3 equals 0. A reminder over here that 0 divided by 2 is 0. Once I'm to this point, I'm going to be exactly where I was on 7 and 8. So leave the a and b on the left, move the c term over here to the right. I get t squared plus 8t, leave some space, equals 3. Now let's figure out what's going to be added to both sides. I take the b term and say 8 divided by 2 and square it. So 8 divided by 2 is 4, squared is 16, which means I'm going to add 16 on the left and to the right. So my new equation becomes t squared plus 8t plus 16 equals 19. So if I've done this correct, which I have, I've created a perfect square trinomial. So that factors to t plus 4 squared equals 19. Now I can square root both sides. And so t plus 4 equals plus or minus square root of 19, and finish it by subtracting 4 from both sides. Okay, let's try again. So let's take a look at 11. 11's got a bunch of things going on. First, it's not even in standard form, it's written as a product. So if you're thinking start by distributing, I agree. I get 6x squared plus 30x equals negative 24. Similar to where we started on 10, I have a leading coefficient. That's not a perfect square, so I want to get rid of it. Divide every term by 6. And so I get x squared plus 5x equals negative 4. Again, notice I left a space in there so I can complete the square. Let's find that c value. I get c equals 5 divided by 2 squared. And so 5 divided by 2 squared is 25 over 4. So I'm going to add 25 over 4 to both sides. Okay? So remember that this will then factor to x plus 5 over 2 squared, okay, equals. So let's turn negative 4 into a fraction also. That's the same as negative 16 over 4 plus 25 over 4. So negative 16 plus 25 would give you 9 over 4. And now we can square root both sides. And 9 over 4 turns out nicely. That gives us x plus 5 over 2 equals plus or minus 3 over 2. And so x equals plus or minus 3 halves minus 5 halves. And notice these have both turned into nice tidy numbers, so we will separate. That will give us 3 halves minus 5 over 2 and negative 3 halves minus 5 over 2. So 3 minus 5, that would be negative 2 over 2 or negative 1. Negative 3 minus 5, negative 8 over 2 or negative 4. So on 10 and 11, we saw examples where the leading coefficient was not 1. We started by dividing out that number to every term so that we could complete the square with perfect squares on the front and the back. Alright, let's do one more. Okay, so in number 12 you see an example of it's obviously not in standard form. We need to rearrange. So let's get the a and b on one side, the c term on the other. I can subtract 3x squared. Okay, I can subtract x. Okay, and that would give me x squared minus 6x plus 28 equals 0. And a reminder, we want to leave a and b on the left, move that c term over here. So I'm going to have x squared minus 6x, leave a space, equals negative 28. Now let's figure out what that missing c term is going to be. So c would equal negative 6 divided by 2 squared, which would be negative 3 squared is 9. So on both sides I'm going to add 9 and add 9. So x squared minus 6x plus 9 equals negative 19. Factor the left, x minus 3 squared. It's minus because the last term is positive, middle term is negative, equals negative 19. I am going to square root both sides. So x minus 3 equals plus or minus I square root 19. Finish by adding 3 to both sides. 3 plus or minus I root 19. So you have 5 good examples of completing the square. Make sure you've taken notes on all of those. Feel free to go back and pause if you need to. Our homework for tonight is page 116, 25 through 38. See you guys on Monday.